Okay, today I want to look at how we can get data across from Microsoft Dynamics Business Central ERP into Snowflake. So this is not an unusual case where people would want to bring data across from one business system of record into a data lake. Snowflake happens to be an awesome database environment. Microsoft Dynamics Business Central is a well-used ERP system, very popular. But beyond that, it's a SQL Server database. So even irrespective of whether you use Microsoft Dynamics as such, this is a guide to getting data from SQL Server into Snowflake via Confluent. So firstly, let's just have a quick look at some of the tables. So Microsoft Dynamics is particularly challenging because actually, you'll have just seen that error message because it has a lot of tables and it times out when you're trying to do discovery. Let me clarify that. So, Microsoft Dynamics uses SQL Server in the back end, but it has a particular design quirk where every company that is made has its own set of tables. And so this is one particular company called Retail Operations. That's a company that appears in our ERP system, and it alone has 4,000 and so tables. If I scroll all the way to the bottom here, these are all the tables and all the fields. So we have 4,165 tables. Now, in this particular ERP database, we happen to have 10 or so companies. Each of those has that many tables. We've got 40,000 tables. And as you saw, actually, when I opened Azure Data Studio, there was an error saying that something timed out, and that was simply me just trying to load the list of tables. And this is a problem with a lot of the tools that we'll try to use, a lot of tools that you can use to migrate data, in that they'll fail when trying to discover the database schema if you have a really big database. Now, why is Microsoft Dynamics like that? It's because it has one set of tables for every company. So, and it prefixes it with the company name and the $sign, but then as well, it has a set of tables for every extension. So if I look, for example, for, let's say, the item table, and this makes it hard to find fields as well, Microsoft Dynamics, I kind of wish they'd done their databases differently, but nevertheless, this is what we've got to work with. So if I look for the item table in particular. Okay, I shouldn't have scrolled all the way to the bottom maybe. Here we go. So item, for example, this is a common thing you might want to look at. And here we go. So with item, you can see we have 1, 2, 3, 4, 5, 6, 7 tables, all called item. So again, the company name, $sign, the table name, $sign, the particular extension that these set of fields belong to. So the default Microsoft Dynamics Business Central installation will have is I guess its own extension. It has a particular GUID and a particular set of tables, but then every other extension you add to your Dynamics system will potentially add another set of tables. Not to everything. You can see, for example, table job queue, whatever it is, and it has one set of tables, and that's from the base Dynamics systems. Same with job GL account, but here we go, job ledger entry. It has extra tables based on some of the extensions. So anyway, there's a huge amount of tables. They've got horrible names. Company $sign, table name $sign, GUID being the extension. So this is the Microsoft Dynamics ERP database. Again, there's a SQL Server database. So everything I'm going to show you applies equally well to SQL Server in general, but I'm specifically talking about Microsoft Dynamics simply because of the challenges that it introduces here with these table names. So if we want to stream data from Confluent into SQL Server, we can into Snowflake, my apologies. We can start by signing ourselves up for a free Confluent account. Now, Confluent, for those who don't know, Confluent is a streaming data environment that's all hosted and provided for you. And what we mean by streaming data is that it has a series of producers that are producing data, that are constantly checking your databases for new data, and it pushes it down a stream, and you have consumers that are listening for that data. This varies from a traditional batch system where you might copy data at night. You might have a nightly process that pulls data from one system and loads it into another. And maybe those systems are tightly coupled. You have an app that specifically pulls data from system A and pushes it into system B. With Confluent, things are very different. You have a streaming set of data. You have many producers and many consumers. You can pull data from particular systems and just push it down the streams, and then you can have applications that are listening for that kind of data. There's no tight coupling between applications A and B. Instead, you have an application that's maybe producing data, and you have applications that are consuming data, and you can react immediately as soon as something changes. You can have apps that are listening for that. So Confluent is really impressive for that. And Confluent, by the way, is a hosted version of Kafka. So Apache Kafka is available for free. You can run it yourself, you can host it yourself. The people who made Kafka originally made it for LinkedIn, and then they released it to Apache to make it free and open source. But the people behind Kafka are the people behind Confluent. So this is effectively, you could consider this for all intents and purposes, the commercial version of Kafka. And in fact, Confluent still today produces 80% of the code that goes into Kafka. So that's Confluent. So if we start by making a cluster, and so we'll create a basic cluster. You could make other clusters that have higher amounts of data and connections and SLA. You can see the uptime SLA for a basic is 99.5 up to 99.9 elsewhere, and so on. But we'll begin with a basic one, and I'll make it in Azure simply because that's where the rest of my data is, and in particular it's in Australia, as you can tell from my accent. And finding that. Okay. Well, there we go. I'll put it in Singapore. And we'll say single zone for now. Okay, so let's continue. Now, Confluent is always telling you the price that you're going to be paying. Okay, you could give it a good name. I'll just call it cluster 0 for the moment. And we can see this is the price to write and to read data and to store data. Okay, so let us launch our cluster. So we're setting up a single zone cluster in Southeast Asia in Singapore on Microsoft Azure. And we don't have any data yet. And that makes sense. So we're going to set up some connectors. Now, you can see we have sinks. Sinks are where you can store data, but sources are where you can pull data. Now, we have a SQL Server database. It's running Microsoft Dynamics. We have three options if I look at Microsoft SQL Server. One uses CDC, Change Data Capture, and so this is good. If you have CDC set up in your database, Change Data Capture will tell you, or tell Confluent, tell any listening app, whenever particular fields have changed, which avoids having to do a lot of polling. It does introduce a bit of load on your database server because every single write or insert or delete or update is making a CDC record, but it's much more efficient for reading. If you don't want to set up CDC, or you're unable to because maybe somebody else administers the data, then the SQL Server source can work in different ways. It can monitor tables based on an incrementing ID or a timestamp or things like that. And then, as mentioned, the sink is for storing data, for writing data. So we're going to use the Microsoft SQL Server source. And now in Kafka or in Confluent, when you publish data or consume data, you do it as a topic. So a topic is a particular naming convention for things you want to use. Now, Confluent will automatically create Kafka topics using the naming convention of your prefix followed by the name of the table. And you can't vary this. You can give it a prefix, or you don't have to. It'll use your table names otherwise. I'm just going to go with table names for the moment, but this table name is going to cause us a problem. And that's because of the way that Microsoft Dynamics loves to put $ in everything. So that's an invalid character in Kafka. So if I continue, now we will add credentials. You might, and you should, you should make your credentials very finely grained. You don't want to give write access, for example, to something that you only want to read. But for now, I'm just going to do some very simple settings, just so we can get on with what I really want to show you. Okay. So now let's add our details. So my database is at a particular IP address, and as always, port 1433, and I'm connecting as myself, and the password is that, and this is the name of the database, because our Business Central implementation is also using LS retail extensions. Okay, now you would need to whitelist Confluent IP addresses against your database server, because of course, you don't want any internet host to necessarily connect to your database. So best practice is to whitelist Confluent IP addresses, which I've already done. So if I continue, okay. Now, here I need to specify some table names, and we don't get the option to browse, which is fine, I guess. It would be nice if this was a bit more visual, but it's not, and that's okay. So, back in Azure Data Studio, I have all these tables. What I've done to save a bit of time is I've captured a couple here. So I'm going to bring in 3 tables, and I'm pasting them there. So these, as you can see, are in the form of the ERP company, $, the table name, $, and the good, then comma, the next set of table. So I've actually got 3 tables here that I want to bring in. It's not an awesome input box, but nevertheless, this is where you specify the tables that we're going to deal with here. And as before, Confluent is going to make a Kafka topic with the name of the table. So it's literally going to make a topic with this name, and that's going to fail, which sucks, because you would think Confluent might like to check for some of these characters, but it doesn't. Anyway, so any Kafka topic is allowed A to Z, uppercase and lowercase, 0 to 9, and a dot and an underscore and a minus. So obviously it's going to fail with a $. Okay. In fact, if I were to continue, I can show you that. Let's do it. So JSON. Why JSON? Because the others require you to set up something else, so I'll just use JSON for now. We've specified these are tables. You can also use views or other things. I'll put in our time zone, which is Australia East. Now, one important thing to note is this schema context. If you, all these, so SQL Server users will well be familiar with the fact that your tables are prefixed by a schema. If you are using anything other than the default DBO, you need to specify it here. Don't put it here as part of the table name. If you have a different schema, you'll put it in here as part of your schema pattern. Here we go. So if you, instead of DBO, if it was I don't know, system.table name, you'd put in system, for example, and that will automatically be catered for in your tables. Now we're going to put in a timestamp column name because our tables have a timestamp, which is literally timestamp. Actually, if I remember rightly, this is not in a format that Confluent likes, so I might take that out in a moment. Okay, so we can specify timestamp or incrementing or bulk as different ways of loading the data. So timestamp and incrementing will try to only get the latest values from tables based on whether the timestamp value has changed or whether the incrementing ID number has changed. If you have an incrementing column name like ID, you'd put it in there. We can specify how often to poll. And we can also specify transforms. We'll look at those transforms in a minute. First, I'm just going to continue, and we'll tell it to make one task. And here we can see the price. This is the price we're going to pay for this connector. So I'll continue and give it a name. Okay, now this is going to fail. So it's Confluent's provisioning our connector, and it's going to fail because it doesn't like the $ in the topic name. Kafka will reject that. Okay, let me reload the page. Is it still provisioning? Okay, still provisioning. Okay, my Confluent connector has been provisioned, and as I expected, it failed. And the reason it failed is because there's an error in the topic names, the Kafka topics, and the error in those Kafka topics is that there's an invalid character, which is namely the $ that Microsoft Dynamics loves to put in its table names. That's an invalid character in Kafka. Confluent makes topic names for you automatically out of the table names. Unfortunately, Confluent doesn't do any sanity checking. It just simply passes it through. So what we need to do to solve that, in our Confluent cluster connector, our SQL Server connector here, is we add a transform. And here's how we can modify things as they flow through. So what I want to look for is a topic regex router. So this is going to take a regular expression and replace it. So to save a bit of time, already made one. Okay, so you'll recall some of my tables look like this. Retail operations, which was the name of a company, $, the name of the table, and then $, and then a good. So we're going to tell this regular expression to look for anything that matches that pattern and then replace it without these $. Because the $ mean something in regular expressions as well, we have to escape them. A $ means the end of the string. So I will simply replace that with a table called item, ledger, entry, and then whatever was after it. So whatever the GUID was. Okay, so we'll add a new SNT as well because we have, you'll remember I brought in 3 tables. So I'm going to look for 3 different patterns. Obviously you can try to make these more generic if you can do so, but for now I'll quickly do this. Okay, so 3 topic regex routers. So we're changing the topic name based on a regular expression and replacing it with something else. Okay, so this time when I save this, we're going to have the topics will be transformed on their way through. That's going to provision. So let's come back in a moment and we'll see how it goes. Okay, welcome back. So now we have a SQL Server connector that is reading data nicely. So now we're going to store it. So we'll use Snowflake as a Snowflake sync, and Snowflake will prompt us for the topic we should use, which can be the topics we've already created. We specify our Kafka credentials, we size it, we review and launch. So we make a Snowflake sync, which is going to save the data. So obviously we need a Snowflake account already, and we need a Snowflake account that with a user that we can write to. Confluent will ask us to make a public key and a primary key. It doesn't connect to Snowflake via a username and password. It connects via a username and a key. So I've done that, and here we now see those tables landing there. Now remember we did the regular expression to rename our topics. So instead of being the literal table names from Microsoft Dynamics ERP with the name of the company first and the $, we have it renamed the way we specified. So this data is now flowing in freely from Confluent, and Confluent stores it in JSON values. So we've effectively got, well hang on, let me show you the literal data. Okay, so if we look at the definition of this table, it effectively has 2 fields, a metadata and a content, both of which are variants. If I browse that data, Okay, and have a look at a preview. You'll see that it actually literally stores all of our values, but in a big text string in a variant. So, which is okay. If we want to look at that in Snowflake, it can handle variants by using by referring to the field colon and I guess the item in that field that we want to look at. So we can now query that values, or we can make a view, we could make a dynamic table, we could do all sorts of things using these data. So this has come across from Confluent. We've used Confluent to make a SQL Server source, and we've used Confluent to make a Snowflake sink. You'll notice that we didn't make a pipeline. At no way did we connect the two ourselves. We simply said the Snowflake sink listens to certain topics, and the SQL Server source publishes certain topics. So you could have many different apps, many different applications, many different things, all publishing different topics or consuming different topics that need not have any knowledge of each other. So that's the value and the beauty of streaming data, and that's what Confluent offers. So anyway, there was a simple example. Well, when I say simple, it was a straightforward example of just get some data from a couple of tables and put it in somewhere else, but made more complex by the fact that Microsoft Dynamics ERP insists on those little dollar signs. So there we go. That's Confluent in a nutshell.